Let's start with one example for the nodal analysis. So this is the circuits for determining the voltage and the current through all the elements. You can see that in this circuit it consists of the voltage source, current source, and some of the resistor that is in series and also in parallel. Assume that we are trying to find the voltage across and the current through all the elements. So the first step will be you have to mark the essential node for each of the element. I already informed in a previous chapter on how to determine the essential node. So first is you have to mark with the X for each of the element, the left and the right side, not consist of the element which is in series. We're not considering the node that sharing with the two element. We are considering the element which sharing more than two element, which we call that as an essential node. So first is mark with X at 10 ohm here. So after you mark the X, and then you have to combine the X so that it will become the essential node, like this one. Here you can combine the X, it will become another node, and then another one here, it also will become another node. So there are three essential nodes, which is the most numbers of branch is selects as the grounds. So first one is a ground, and the two will be the node voltage, which is V1 and V2. As for the second step, we choose the reference node. Choose the most numbers of branch as a ground. Mark the reference node with the earth sign here. The reference node is the node from where all the others node voltage, the node that is considered to be 0 volt. The next step, assign unknown node voltage. For example, here we assign as V1 and here is V2. The step number 4, decides on numbers of equation required. First point will be decide on the numbers of equation required to solve the circuits. Reference to the example, there are two unknown, which is V1 and V2. So this is the step number 5 to perform the KCL at the selected node. We assume that KCL is performed with the currents going out of the node as a positive and assume all the currents exit the node. So, for example, in this circuit, we assume all the current is exit. Now for the first equation, you have to find the equation I for each of the branch, which is you can consider here for the first branch here, the I will be V1 minus 5 over 10. And for here, V over 8. And then for here, V1 minus V2 over 4. We are considering the current is exit the node by considering here is positive polarity and here is the positive polarity, also same as here. So V1 is a positive and then the V2 is a negative. So the numbers of branch for this node is 3 is equal to summations of equation, which is I at this branch plus with the I second branch and then plus with the I at the third branch. You can see the equation is stated in the first equation. For the KCL node 2, which is the node V2, we still assume that the current is exit the node, so that we are considering the V2 will subtract the other voltage. So here is the polarity of the voltage for each of the elements. So we assume that here as the first current for the node V2, this one is the second, third, and fourth. For the first equation for currents, V2 at the positive polarity minus with the V1 over 4 for this one. For the second I, you can see that the branch is already give you the values of current, which is the 3A, but the difference is the difference direction, which is you are considering the current is exit, but the current source is showing the opposite direction, so it means that the current showing in this branch is minus 3. As for the third branch, the equation for I will be V2 minus 0 over 4, and then you can choose V2 over 4. No need to considering the 0. And then for the next currents, V2 minus 0 over 2 or V2 over 2. Add all the equation for that branch so that it will become the equation number 2. Step number 6, and then you have to solve the equation by using any kinds of method, or by applying a Cramer rules or using a calculator. So from here, from the first equation here, then you have to group the numbers. Grouping for group V1 and grouping for group V2. And then left it with this equation. I suggest that you left the equation with these kinds of number. And then from 2, solve the equation by groupings the V2 and V1. And then you get the answer here. Substitute the final equation to the Kramer's, and then by using a calculator, you can get the value of V1 is 3.03 volt and V2 is 3.76. If you take a look with the answer, it shows that the V1 as shown in this circuit is 3.03 and then the V2 is 3.76. Okay, in order to know the values of the currents in the branch, use the voltage as R and divide it with R. If the branch do not consist of R, use KCL by using other branch. So as shown in here, take a look at this figure. The Vx will be the positive minus with the negative, which is V1 minus V2. And then V2 is equal to V3M, V4 ohm, and then V2 ohm because the element is in parallel. And then for the V1 will equal to the Vx ohm here. So voltage V1 and V2 is from the nodes to the ground. Okay, and then from this node to the ground.